Now we'll move on to imagination, power, and profit. To round out our general session today, we have Tim Scott from Caterpillar and Jake Jacobsen of Ring Power. They will be giving us insight into the Harvest Power facility right here in Orlando. This facility is a great example of a modern waste-to-energy facility that delivers ongoing value for its owners. The intent of the presentation is to discuss with the audience the keys to success for the local power generation system and to share a view of the North American business landscape and the increasing utilization of natural gas. Please extend a big warm welcome to Tim and Jake.
Never heard that on an entrance when I come in. That must be for you.
All right. Good morning, everyone. I'm Tim Scott. This is Jake, and we're going to spend a few minutes talking about imagination, power, and profit, which I hope is an interesting title to a presentation or maybe a B-class movie. I don't know, Charlie. But anyway, for us, this topic's actually a pretty good news story in that we, this industry, get to help manage what is a waste and do something useful with it, right? So we'll unpack that a little bit in this presentation. But before we get into that, I will say that a couple weeks ago, Kim called me. Kim, the organizer, Kim Giles, and she said, "Hey, Tim, I know you're a newcomer because it is the first time that I've come to this event." And she said, "Be sure you don't do a commercial, right? Because EGSA is not about doing commercials." And I'm like, "Right, Kim, I got it. I won't make a commercial." So I promise you there's only one slide that even mentions the name of my company. We'll get to that in a bit, right? But I will do a commercial for something I did last week, right? So actually yesterday morning, I came from Cuba, and I spent a week with my family in Cuba, traveling around, visiting the countryside. And I will say that's something you guys ought to do once in your life. There's a lot of really nice, interesting people who are actually thrilled that now U.S. citizens are coming to Cuba, alongside of Canadians and Europeans who've been coming to Cuba for decades, right? So great environment. But is there a tie to Cuba in this presentation? In fact, there is. And if I find the clicker, Hal, do you have the clicker? Did you hide that from me? There it is. I got it. Got it. I need to click once here to that connection to Cuba in this presentation, because Jake, there is actually one, believe it or not. And on the right-hand side of the screen, you see a picture of pigs. And one of the popular dishes that's really good in Cuba is pork, right? You can drive along the road, you can see plenty of places that are advertising for sandwiches from lechon, right? A good pork sandwiches, and I had several of those last week. But in this slide, you kind of get a feel for the topic here that we're addressing, which ranges from pigs to beer bottling, right? And so what's the tie here is that all of these images in this collage produce organics. They have leftover organics which have to be dealt with and can be converted into something useful, right? So in beer bottling, after you finish making beer, there's leftover barley and whey, and it's got a lot of energy content. You got to deal with it. So if you put it in an anaerobic digester, you know what comes out after a while? You know, some smell and a lot of methane, right? Same thing for a pig farm. If you're have 1,000 hogs at your pig farm, you know what happens every day? Besides getting fatter pigs, you got a lot of shit, right? It's just you got to deal with it, right? And you can fling it out into the field for a while, and then your neighbors get upset because it stinks, right? And the water run off, and you mess up the pH of the soil. And so, you know, you have to professionally manage that. And so, you know, here we're in an environment where that is increasingly regulated, and it's just the right thing to do, right? So also with dairy cows, the same issue, right? You got to deal with the manure. Landfills, there's a picture here also of landfills, you know, for a good 20 to 30 years, the landfill industry have been implementing what we call sanitary landfills, right? So those at the bottom have 2 layers of plastic that's very thick. At the top, they have a good layer of clay, right? That makes a pretty good oven. that for the next 20 or 30 years keeps most of the air out, keeps most of the water out, and thus it creates a lot of methane that needs to be managed, right? And so all of these sites can feed methane to, at the top of the screen you see a power station, to create something useful, right? To create electricity. The fuel that comes out is a pretty good quality. It has about half the energy content of the fuel you get from your natural gas pipeline, which is more than good enough to create electricity. Right? There's some contaminants. Jake will talk a little bit about contaminants that can be dealt with. Some of you in the room actually help us with that. But it's a good fuel, and it's a part of the good news story. So, what else is good news? We here in the room, all of us, are helping manage methane, right? And methane molecule, as you might know, is a molecule that has 23 times the potential for global warming compared to CO2. All right, so it makes a lot of sense to try to do something to manage that, and it makes even a lot more sense to do something with it that's useful and valuable and does something to help the environment as well as provide value to an electric utility, for example, right? It's also interesting, a lot of states today now have renewable portfolio standards where they're asking and obligating their energy mix in a state to increase the amount of renewables that are a part of the energy mix. So the energy mix is shown here, and you can see it says World Energy Man. North America is not so different from this in terms of our energy mix. But during the past 15 to 20 years, right, renewables have really come into play, right? And very visibly, we see that in wind and photovoltaics, right? We see plenty of utility scale photovoltaics and wind farms now around the U.S. But in this are also organics, right? The increasing use of organics to provide electricity. So that's a piece of what's growing here as well, right? So that's helping the market grow. One thing that's been valuable for us is that the skills and equipment that are used in our on-site power generation that we know from diesel and natural gas really also apply in this area of harvesting methane from these fuel sources I talked about. It is a transferable skill. Not too much new is needed. Right? So it makes it a growth opportunity for us, and that's been good news. Other thing that's helped the market grow is that we here in the room have gotten better. Right? In the past 10 to 20 years, we're faster, we're better able to control our equipment. Right? So what I mean by that is, if you think about a generator set application, here we're using gas, and gas gensets today are much more efficient than they were 20 years ago. Right? So for a given amount of methane that you get from one of these sites, you create more electricity. That's good for the economics. Right? Power density. From a generator set today, you get a lot higher power output for a given genset. Right? So that tends to help your installed costs. Your dollar per kilowatt typically is better today compared to the past because of much better power density. Reliability, durability are improved, and also the ability to control, right? We have much better opportunities to control and monitor and faster processors, so we respond better. All of that's been good for on-site power applications in this industry, right? Because at the end of the day, they have to make money, right? Nobody's going to take money from their own pocket and invest in any of these power sites unless they create value, right? And so today, through the work that all of us have done, those projects look better on paper. And Jake's going to give an example of that in his slides. So last piece about the market that we talk about here, there's a bunch of dots on this screen, looks really busy, but these are places today in the U.S. that actually are executing this, right? They harness methane and create electricity, right? The red dots are all agricultural sites, so that's pigs and swine and some chickens as well. Yellow dots are landfills. Right? Landfills have been almost always harnessing methane to create electricity or to send natural gas to the pipeline. Wastewater are the blue dots, right? Municipal, all cities and municipals typically have a wastewater treatment plant, and it's increasingly popular to put a generator set there to provide power for that facility and maybe even export some power back to the grid. And the last part is food waste, right? Food waste in a digester, that's the green dots. There's fewer of those, but this is a piece of the market that's starting to get new looks, right? Starting to get fresh looks, at least in part because today at landfills, there are regulations or even regulations getting stronger that limit the amount of organics or prohibit organics in some cases from going to a landfill, right? So you still have to deal with those in some way. So the food part of the organics frequently is looked at for application in a big food digester, right? Again, to create methane. So that's a newer part of the market that's expanding a bit faster than the other sectors. So all these are interesting. All these are kind of a good news story where we're doing something useful with what is really a pure waste, right? So I'm going to invite Jake now to talk about Harvest Power. Hal mentioned it, Harvest Power. It's a site just a few miles from here that gathers a lot of food waste every day from the area, maybe even from this hotel, I don't know, but it's doing something useful with it. So, Jake, your turn.
I get the clicker.
Sorry, I messed up, Jake. I had one slide here I was going to talk. I promised only one slide about caterpillars. This is the one. So I work for Caterpillar. Caterpillar's in three businesses, really. The classic business of machines that you see along the side of the road or building dams. Cat's in resource industries, that's mining, which is a really slow part of the business today. Miners are really not investing in much, so we're kind of waiting for that to come back someday. And then energy and transportation, right? Power generation, we love that part of the business, as well as marine and petroleum and locomotives. So that's kind of Caterpillar today. End of commercial. Jake, now you're on.
Good morning, and thank you for the opportunity to speak. I'm Jake. I'll be covering the technical review of one of Caterpillar and Ring Power's biofueled tri-generation projects. Now, what I think a lot of you don't know, and I didn't know this morning, is there's a timer right up over on the right-hand side, and they just fixed it. But it scared me a little bit because it didn't start timing Tim, and I thought he was going to go for a little while. I have you for 30 minutes. Let's assume it's going to seem like a lot longer than that with a technical review. If those words don't have you looking to the back of the door, by the time I'm finished, I can probably win some hearts and minds for that. We did put in a few slides for some entertainment. I hope you find them funny. If you don't, I apologize. If you do, maybe we should get a support group together. And is it the bottom one?
On the top.
Oh.
There you go.
So combined heat and power. Prepare to be amazed. Maybe not so much. So we have to start somewhere with a technical review and the opportunity for the folks in the room. There's a wide audience here with a range of technical and financial skills. I want to give you a little bit of background. It should go rather quickly. Some folks may talk about cogeneration, CHP, combined heat and power. These will be shortened. Tri-generation, quad generation. All of these is one form of energy that you may find useful in an application to allow a customer to use it at their location. In our particular industry, on the power generation side for recips, this also could be used for other forms of chemical to mechanical to electrical. We'll talk about that very briefly in a second. We get a fuel that's inputted into the system. That can be a natural gas, it can be a biofuel, any kind of fuel. Diesel fuel could actually be used for combined heat and power and is in certain places throughout the world. The fuel energy content goes into the system, which is a chemical, and it's converted first mechanically, and that is on this particular graph put out as electric power. It drives a generator. I know there's a lot of generator folks in the room because I've not been to an EGSA conference before, and yet I recognize a lot of familiar faces. But as you can see, there are other forms of energy that are coming out of that which are non-traditional for some folks. A lot of these are in the form of heat, but they can be used for other conversions. We won't get too far into that. But let's assume everyone in here has some basic understanding of a car. So let's get this down to the layman and the customer level for some parts. Once they've paid for the fuel that goes in that car, anything that they can get out of it that's not the primary mover of driving the car forward is somewhat relatively free, or it's a waste if it's going to come out of the process naturally. So you're in Florida, if you've been driving around, you may see one of the hoods up on a car and steam is coming out of the front end of it. I don't think that they'll see that as beneficial use, but that is one use of the heat. That's the front end of the car on the radiator set is probably improperly ventilating. And then there's the exhaust heat that comes out of the back. And as you can see, the exhaust heat is more significant than I think most people realize. So this is a very busy slide. As the gas fuel, in our case, comes into the engine and is converted, I'm trying to give a relative idea of what some of the temperatures are and the uses for them, so that I don't have to go into all of them. I'm not going to read slides to folks inside here. If someone wants to review these slides afterwards, I've been assured that they can be made available. But as you can see, there's a lot of applications, and one of the things that you may not realize, some people have seen an absorption chiller, is the conversion from the exhaust gas can be used, and we can have combined cycle sets for that, in other words, 2 stages. We can create, through an absorption chiller process, a chilled water coming from the reverse process as steam. It's just a different way of applying energy into a refrigerated system. So you saw that slide, now there'll be a test. So let's focus on the digester gas and give you the example of the project, which is Harvest Power. It's been mentioned a few times. It is right down the road. It is in the middle of Disney's property, and what it does is takes some waste gas created from wastewater treatment center that uses waste food from local vendors, the trash. It gets separated on site, and it also uniquely takes in a little bit of animal kingdom waste. So this is Harvest Power. It's the Energy Garden, and we're gonna reference some of the equipment that's on here. You can see some of the pumps. I don't know if the laser pointer's on here, but it probably isn't effective for a group this size. But towards the back, you can see the white radiators on top of the building. That's where the power generators are. But the entirety of everything you see in here is creating this process. Wow, I'm really not going to read this one to you. But in general, the idea here is that we're not talking about just the electric power generation. Once you have energy and you're talking to a customer, in our case, you're trying to get a full scope of all their energy consumption points and not just focus on the electric generation, which clearly is in the name of the organization I'm speaking to. But as a byproduct of that, I can provide other value. And in this case, even though the electric capacity for the plant is only generating at 3.2 megawatts, the total energy that I'm offsetting for this plant is 5.4 megawatts. So I talked about the streams coming in, and I do want to spend a little bit of time on this particular slide. There's the sewage and wastewater section of it that is moving, and it is combined with the animal kingdom waste before it moves into that facility. And so it's a typical facility for wastewater treatment. It goes into settling ponds in different stages, and then ultimately the solids will fall out of it, be collected as cake. And in a traditional wastewater treatment plant, that cake will be either sent to an incinerator or it will be delivered to a landfill, and then clean potable water will be returned back for use inside the water park. In this case, the substrate is being identified as the cake material. It gets put into an additional settling tank to dry it out just a little bit more, and there were several tanks there. Those are spares alternating back and forth, so that you can get to the anaerobic digester. Now, the anaerobic digester is basically your stomach. And its job is to create an environment that will allow you, actually it's more along your intestines to be honest with you, it's going to create a lot of gas as it tries to break down anything that's organic that's left in the process before and get the energy from it. Now, we may not be able to use that gas, but the engine can. And as you'll see, the gas comes out and goes into the plant, and then some of the heat goes back into the anaerobic digester to try and create that ideal environment for the creation. Some of the heat coming off the exhaust uses a superheated fluid, and that is sent into a dryer and blown over after the digester material comes out. It is now been decomposed to a state where it can be sterilized and then used in other ways. So does anyone in here, I know I'm probably boring everyone to death, but does anyone in here come from a farm or had a compost heap or a compost barrel out back? The digester's job is to do exactly that. We put in some material that will break down. You have to spin it over, but it gets hot, it smokes. If you've ever been out on a farm, you can see a little bit of steam coming off of it on a cold morning. But at the end of it, we use it as fertilizer and put it back out on a field. In this case, they sell it, they bag it and sell it. It also has other uses. So if you do this on a farm, which we have done, there's one in Gainesville, we use it as a cow farm. They'll use it as an alternative for bedding material. It's so sterile when it comes out. It doesn't have any smell left to it. It's been composted and decomposing to the point where it's no longer a hazard to handle. Wow, I hope you really got that slide. So now that I've walked you through the process, and the point of that wasn't to get everyone in here educated for that portion, but how can the folks in this room participate? Now, I am very new to the EXIT organization. I've never been to a meeting. I apologize for that. I've had the benefit of EXIT-trained technicians when I worked at Caterpillar and at Ring Power, who I've worked with, and I have enjoyed all of the training you folks have provided out into the industry, and unfortunately not been privy to come to one of these events. But just by a show of hands, can I get the number of folks who are working in either equipment cells or somewhere along those lines that are inside this room? Is that about 90% plus? No, just in general for electric power generation. Because the point of this is not to educate you into a market that you can't participate. In fact, it's really to educate you in a market that more than likely you can participate more than you might even normally do so. So I want to walk through some of the equipment. Now, first in the tank formation portion of it, I'm gathering that there's not too many folks in this room, but what you may not understand is that the folks who are going to be providing the MCCs and the motor control, the distribution, everything along the lines of what it takes to get that substrate and any of the processes into it, you could participate too, and there is distribution. As it moves into the dryer compressor, there are chillers, there are pumps, there are blowers, somewhat like a radiator system, depending on knockouts and dryouts. There's gas filtering. And then finally, it will come into the combined heat and power plant, wherever that may be. You could look at an enclosure. You're looking at, you're going to have some boiler inside there, a Hertzig. If you're not using that, you probably have a silencer, muffler system. You have a lot of equipment that folks in this room are going to be participating to. And it's not traditional, at least yet in North America, or customary, for that to be provided from the OEM. I think that's the important part here, is that they're very custom at this point, and very rarely do you see somebody with an off-the-shelf project that you can't participate or provide some value. And then we get to the electrical distribution side of it. As you can see, there's a radiator on top, the electrical distribution switchgear and transformers. I know I've already seen a few folks for the switchgear distribution in this room. So I just wanted to, we're going to revisit that in just a second. But now, why would somebody want to do that? Tim mentioned earlier, I think a lot of folks have a bad view of renewable energy when we say that. We say renewable energy, and somebody in the back of their mind immediately has politicized that to one side or the other. But these projects do make money, and they can stand on their own. And it's not unique, especially in the United States, to have a carbon credit level so low that really people just turn in the paperwork so that they can establish the train for in the future. So the revenue streams, so that there's a tipping fee. The cake, the material that's inside that digester was going to go through the process and be dried out. But it was going to be sent to a landfill and then buried, where it would probably produce some sort of gas, and when you have enough of it, somebody will do a power generation project on there. But until that time, it would be flared. And that may take 5 to 10 years. This is going to take between 20 and 30 days when we put it into a digester. So we can take the tipping fee of that material, which no longer has to go through the landfill, and apply it as a revenue stream to the customer. And then the municipal wastewater treatment solids, there are value by the solids so that they are figuring out, and I apologize, I got that backwards, but the wastewater solids versus the food tipping services, or how I have those set up, is the waste solids for animal kingdom, and then any of the food solids will also need to go into the system. So electrical export to utility, that's where everybody in this room should be somewhat familiar. We're going to be making power, and that power is going to go out on the distribution grid or be offsetting somebody's costs at around 12 cents. The fertilizer section of it, this comes out as bags. You can buy the Harvest Power fertilizer literally at the facility, but more than likely at one of the local retailers, or you can order it online. And then there are the carbon credits, which really aren't a participant to any of the major projects we're working on inside North America. So what are some of the expenses? Well, I'm not going to read every one of these, but I do want to highlight the equipment manufacturers inside this room. You folks have a huge opportunity here for a wide and diverse amount of equipment to be delivered onto a local site. When you think about it, I mean, most specifically, you're looking at the side over here. That's an exhaust boiler system. That's not put in place of the muffler always. The muffler still would be sold like a normal system, but now you have an extra piece of equipment. And now you're looking at the bottom screen. Those are two blowers. Those are put in place because these don't have pressure delivered from natural gas, so there's an extra piece of equipment. These are all items that would be, they're not taking away from a project you would normally do for electric power generation. Each one of these is an additional piece of equipment. So looking over to on this, that's an H2S scrubber. Again, an additional piece of equipment that's not necessary in a standard electric power generation project. I put a lot of information onto this. Every project is unique. I mean, they range from 500 kW and go up to 20 megawatts plus. As having the standard, there's some industry standards and establishments for financial feasibility, and in case you wanted to kind of delve into this, I just provided this information so you folks have some level of awareness about how to translate these costs. Did it work? All right. So generator set service. I mean, for my organization, I work at Ring Power, not trying to make that into a commercial set here, but for a lot of folks inside this room, I think we get into the capitalized selling of equipment, but most electric power generation in the United States doesn't run continuously, and therefore it doesn't get a level of service that you would say is going to outpace the capital sale. Every single continuous project that we've done so far, and almost every one that I've ever dealt with, will end up with more maintenance cost than it will for initial capital costs over a short period between 6 and 8 years. That's almost what you're looking at. So when somebody says, well, you know, hey, we got the magic bull, we had a $4 million project. If that was a $4 million continuous project, that would be another $4 million worth of revenue, typically to the folks who provided the original equipment and or can provide service to that equipment. So if you provided the generator set, provided the switchgear, provided the pumps, that project will resell itself long before the end of service life of a standby piece of equipment. So just kind of, I went through some, these aren't always the same, I just kind of threw out some service numbers. So in summary, and Vaughn's in the back there, he knows that I'm never before the time, so apparently the clock is wrong. What does this mean to us? I mean, I've kind of covered most of it. There is a lot of opportunity for the folks inside this room to participate in an emerging industry. It has been around a long time, but it hasn't had growth or legs like it has over the last several years. There is a lot of revolving revenue, which is the sustainable type for your organization, which will maintain you through these troughs and peaks and valleys that we're going through in the energy business. I mean, uniquely, I started on the electric power side of this in the middle of Enron, so that was probably not a good time to enter over from the engine manufacturing side. And then it's a green energy, which you have to feel good about, but not feel good about, oh, I feel so good I want to give people my money. These things make money. This isn't a tax benefit. There aren't tons of write-offs for it. We're not subsidized to the extent of, say, solar or anything like that. So, I mean, it's important that that message be put out there, that there are sustainable, cost-beneficial green energy projects. And then uniquely for the park and harvest power, there's less smell and a small ecological footprint rather than have the collection site, take it over to a landfill, spread it all out, stack it up high, do whatever you're going to do. These folks are able to put all this in a very small section in the middle of one of the largest entertainment parks in the United States without complaint. It's actually reduced smell because it processes in such a small area and then gets it into the digester where the smell is captured. So, and now a test. I actually won't test anybody, but we have some questions, and as I mentioned to Tim earlier, we may actually have some answers.
Thanks, Jake. So, yeah, open for any questions anybody might have.
Rather than the facility funding the installation and paying for maintenance, has any potential customer come to you with a proposition where you capitalize all the equipment, you also monetize the incoming the waste streams that turn into money, like the fertilizer and getting the CO2 credits, and you just charge power by the hour? Is there such an animal out there?
There are. So, one, we do have financing available. Most of it is on the equipment side. The unfortunate variability due to the gas in the nature of this particular project, anytime you're working with a digester or you're working in agriculture, you may have a collapse of some of the bugs inside the system. And if you do have a collapse that's due to an external, it's difficult to find someone who would insure that process or who can maintain and guarantee it. So we do have some projects that are working on that where natural gas is used as an alternative during a collapse period, and then that part is shared throughout several parties. But yeah, there's a lot of unique financing that goes on inside this, but yes, very much so.
Yeah, I'd add, I mean, this is one of the key challenges in the segment is availability of finance, because a bank, typically, they want to see a secure fuel supply. You know, show me your secure fuel supply for 10 years. And show me your power purchase agreement, right? And then you've got end-to-end and secure financing. And it's not always easy to show that upfront fuel supply, right? So this is part of the challenge, and I know there's some banks that work pretty well in that space, and others are shy there. So this is one of the opportunities that there are to move the industry forward if there were more banking entities very familiar with how the business operates.
Steve.
Okay. I was just wondering if you experienced any hazards with the overall installation, but specific to the hydrogen sulfide. Any challenges there?
No challenges whatsoever. So anytime you're dealing with a gas, each gas stream is somewhat unique. We talked about a biofuel today, and that biofuel is based on digester. There are the common fuel types are kind of lumped into segments. We probably won't talk about coal seam gas today, but natural gas, landfill gas, and digester gas are probably the most common uses, and then with a little bit of propane in the islands. So I would say those four gases, breaking them down, each one of them has unique characteristics of what you're looking for and what you have to maybe scrub the gas for. And then Steve is talking about, if we go back to there was a picture with some large tanks on it, and the gas passes through that because it has a lot of H2S, sulfur, inside the gas. And you need to remove that, otherwise it will combine with water and then start eating up part components. Uniquely, this project has, as you saw, the large tanks. So they have an H2S cleaning that was put in at the time of the project started. And then about 3 weeks before the project started, they moved to a process on the water treatment side, which added a metal chelate, which functionally did the exact same thing. It removed the H2S, but it did it on the water treatment side. So we've had that system locked out for 3.5 years now. So on this particular project, none whatsoever, because as it happens, the wastewater treatment engineers turned out they needed it for part of their processing equipment and solved it before it became a problem for us to correct.
So we also would provide some specific maintenance guidelines for use of these kinds of fuels that you mentioned. They each have their own guidelines, and you're going to be using different oils with a higher TBN to counteract things you might find in the fuel. And oil analysis, right? We know how critical that is. Well, it's especially critical because we're talking about continuous operation. So that's the first place to detect any things that might show up, like hydrogen sulfide or other contaminants.
Well, that was my question, was the oil consideration.
Yeah.
Because of the fuel, and
So
you just can't put any old oil in something like this.
That's right.
That is true. Nor can you put the standard coolant in. There's a specific coolant for gas operating engines. Different manufacturers have different levels of. The most specific to this would probably be the ash content and a stable TAN TBN, which is a total acid number, total base number. That's basically a oil's ability to resist, let's just break it down to saying a pH change, even though that's not exactly what it's doing, and the ash content will be elevated, which may have a problem in a diesel engine because it'll probably gum something up. So, I mean, when it comes down to it, the selection of oil is also project specific. As you can tell, I mean, there isn't any, I shouldn't say any, but it's very rare that we go from one project to the next and there isn't some variability. That's great for most of the folks in this room. If you think about it, I can call up any manufacturer that I want for a power generation system. I can get a transfer switch from almost anybody. I need people like you folks who are engaged into the industry to come out, work with the customer, participate to an opportunity to success. Caterpillar can't tell us what to do in the field with authority in such a way that will lead to success on these projects. We have to interact with them, and I have to interact. Bill caught me outside earlier, and we're talking about that. He's retired now, which is a shame, but we're going to bring him back around for something, because he had the mindset to work with us and understand that I can't take what we did successfully last project and apply it to this one without oversight. It's not just boilerplate spec. I mean, every person in this room should be encouraged by that. I don't want it to be that complex, but the fact that it is allows us a lot of latitude and some security to obtaining these skills and moving forward in careers.
Have you guys looked at adopting some of the aspects of the European model for this application? The way they're adopting biogas applications for both landfill and digester applications?
The engine that's used, I'm not sure exactly how to answer the question, because maybe I believe you're asking a standard base platform for multiple gas streams? Is that the question?
No, they're actually adopting it for power generation as well as removing the different contaminants from the atmosphere. It's beneficial because the bio applications are releasing methanes, NH2S, and high content, which is about 9 times faster accelerating the greenhouse effect as opposed to CO alone.
Let me say this on this part then. There are several manufacturers. I'm not sure all the manufacturers are represented here, but take Caterpillar, for example, and I have competitors that have roughly done the same thing. They have multiple platforms that service overlapping traditional nodes, but are able to accept different types of fuels and the constituents inside them. So I liken them when I'm talking to a customer about we need to determine on a project very quickly in the beginning about whether or not the customer wants to buy a fuel-efficient car which requires that I pave the road, clean the fuel? Or is the fuel pretty much already a dirt road and a pickup truck will work? And then I model those two together financially. I mean, if the road isn't there whatsoever, then then it's pretty easy to make that decision because the capital cost says go ahead and do the whole project. You already got this. You're already getting it cleared out. You might as well just pave it all the way to pavement. Get the efficient model. But if somebody comes to me and they have a dirt road, gas, right? I have a unit that on a pickup truck that can go up and down that road pretty much every day. I do lose some fuel efficiency, but from a cost aspect, I can probably make it work. Mm-hmm. To blindly move forward and say this is where we're going to go. Emissions isn't typically a factor. I mean, I can look at some of the factors related to the constituents of the exhaust, but for the most part, that's what I'm trying to help a customer make that determination. If we just moved it all down and said clean the gas entirely, I think the problem that I have there is that would need to be driven by a manufacturer who doesn't want the customer to have that flexibility, because I don't think it's necessary. Does that answer that?
No.
No? I'm just saying, I don't think we should be going, maybe I'll sum it up to this. I don't think we should go down that path of cleaning all the gas before it enters into any system. Yeah. I think that's a disadvantage to the customers financially.
Yeah. So from a sales angle.
Yeah. I'm talking about using it as a sales angle because when you're talking about green, the solar, the wind guys always talk about how efficient they are and how they're a benefit. Okay. Yeah. There is a benefit to getting rid of the biogas and using and generating electricity at the same time.
Right.
And that's what I think needs to be noticed is that just because it's a recip or just because it's some other type of engine doesn't mean it's bad.
Yeah. Yeah.
It has benefits.
Yeah, that's right. I mean, here the recip, even some turbines, smaller turbines, can take this waste and turn it into a benefit. So in Western Europe, we have. There's probably not as many applications, but similar idea, right? Especially in Germany. Germany's been very leading the way, in wind and solar, and in agricultural sector, right? They probably have per capita the most applications of agricultural digesters from anywhere in the world, right?
As a matter of fact, all the farms, the major farm industries that have dairies, pig farms, that's what they're doing.
Yeah.
They're converting their dairy farm, part of it, to a node for energy generation and for biogas applications for other things, domestic use.
Right. And frankly, we've even seen interest from European suppliers coming this way. Right? They're not busy enough in Europe, so we're showing them show up.
Sorry, I misanswered your question. I thought you were asking a different question.
Right.
What was the timeline from initial discussion with the customer to when you got the plant online? I guess the total length of the project.
Let's see, matriculation. Rather than talk about this one, because this some of the discussion was done and the decisions were economically made before the power determination was there. Harvest Power, if you were to go on their website, has a large focus on taking food waste and turning it into fertilizer in the past. They just, to the scale to get to this level to power generate, so they did that in stages. Let me say this. It's 36 months. If you get a project and a customer wants to talk about it and you're just making them aware for the first time, if it's less than 36 months, congratulations. It is a long, arduous process. There is a lot of feasibility, risk mitigation, the determination for everything from air permitting to land usage. It is a long process, and it's an alternative in many cases, right? When I first go talk to a customer, depending on who that customer is, at least part of the conversation is you're an alternative energy. Not like alternative energy in the way that most people are using. I'm an alternative to your traditional energy provider. The gas company delivering you gas and the electric power company delivering you electricity. I am the alternative to that in a lot of cases, and I need that to be an integrated part of the project because it's such a large section of the finances. So we don't talk to very few people who would do one in under 3 years. And that's just where the industry is right now. I wish it would take a little bit less time, but thank you for asking.
Hal's in charge here.
Question right here.
Yeah.
This I think will be our last question.
Yeah.
If that's okay. Okay.
Do you guys figure in the ROI of transmission? So when you're doing your project, you tend to be at a dairy farm or a landfill. Typically, the distribution isn't there because that house requirement doesn't need that
Small,
power plant. So now you've got to build some mechanism of transmission out to the grid. So does that factor into your number?
Yes. No, we do that on our side. So you'll take it all the way to typically a recloser somewhere that'll be at the property, and then distribution to that. So, aerial is probably one of the more, aerial barrel. We'll figure that out with them, and they may put a vault, but that's pretty rare unless it's downtown. So we're working on a project in St. Pete, another one in Pinellas County. Both of those are in a vaulted service, but out in an agricultural rural area, it's more traditional to have aerial service. We'll take it all the way to the recloser, and then we'll work with them on their distribution side, whatever they have. If it's the closest substation, will they allow radio transmission for anti-islanding, things like that. So, but that's all on our side. We have to make, for the most part, it's such a it's not the standard industry, so it takes specialized knowledge of it. And with that, we kind of have to have all of our ducks in a row. That's what takes so long. We have to gather tons of information, but yep, that's part of it. So even if transformers step up, like a GSU generator step up, we'll have all that.
Okay. Tim,
Thank you so much. Thank you.
Thank you.
Thank you.